All right, so parametric equations now with trig functions. So as you've noticed, what we're really doing is basically just trying to eliminate the t with substitution to get it back into a Cartesian equation, which gives us the tracks, our shape, basically the graph we're going to use. And then we use the parametric equations to figure out what's the direction along that track. So we're making a track and then some sort of direction on it. So substitution, let's do that first. So we have x equals sine t. And y equals, well, cosecant t is 1 over sine t. You always want to rewrite them in terms of sine and cosine. It makes it a nice, easy thing to deal with. So now you can see, well, my x is sine of t. That's a sine of t. So I now know that y equals 1 over x. And so that would be our Cartesian equation. So we know it's going to be that rational function right there and there. So we just have to use our parameter t from 0 to pi over 2, not including 0. So why is it not including 0? Well, let's plug it in. If I plug in 0, sine would give me 0, but if I plug 0 into cosecant, that is 1 over sine. And you can already see that here, we don't like it. That's undefined. And then we know that for sine, it's going to go all the way to pi over 2 because we know how our sine looks. It has that period of it goes just like that, right? All the way back. So it gives us those 4 little marks between 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we know at pi over 2, it's 1. And so you can see that our sine would go from 0 to 1, but not including 0, which means our x value is going to go from 0 to 1. Now our cosecant, again, is just the reciprocal of sine, so it's all those fractions. So if you take and flip a fraction like a half, it becomes 2, third becomes 3. We also know that the graph of our cosecant does this, right? So we know that our y here is just going to be greater than 1, but also equal to 1. So at pi over 2, you would get 1, because if you flip 1, you get 1. So our y is going to go from greater than or equal to 1. And you could verify this with your calculator. So we plug x equals sine of t and y equals 1 over sine of t. Change our window to 0 and pi over 2. And you hit graph, and you can see there's our graph. It's going off to infinity, which we already know what a cosecant would do. So remember, it's going to go off to infinity at 0. So the y value is going to be greater than or equal to 1. And then you can also look at it with your table. You can see that at 0, we have our error, right? And so that's where our infinity is, but then we go to 1 and 1 at our pi over 2. And all I've done is taken my table set. I started at 0, and I put in pi over 4. It's a nice one. You could do pi over 8, anything that is that divisible. Okay, so then we get our graph. It looks like that. We get 1, 1. Oops, let me do this again. 1, 1. That's our y value, 1, 1. And then the reason I'm going this direction, that's 1, 1, and it's got that vertical asymptote here because this is our rational function, right? So we know it's going to do that. So that's another way you can tell that our y is greater than or equal to 1. And we're starting here at 0 undefined, so up here, right? Can't really put a point there, but you can see where my points would go because we are ending at 1, 1, which means our direction would be this way. So if you just follow your table, it'll tell you where to go. And then you look at your graph in Desmos. I've already plugged in my x and my y coordinate. I started at 0 because that's what we're supposed to do. And I got it from 0 to pi over 2. Hit play. And there it is. There's my motion. So you can see it came down from way up there and then stops right there. Okay, so that's our first one. That's just direct substitutions. You're going to take 1 for the x, which is sine of t, and plug it right back in. So if you can see that the other one is just made up of that x, then you just do direct substitution. Now, the second type, is you're going to see something like this, sine and cosine. So your x is a sine, and they have exactly the same coefficient for theta, giving them the same period. And so that's when you do this. We know that sine squared theta over 2 plus cosine squared theta over 2 is equal to 1. So we use our basic Pythagorean identity to give us an equation that we can now replace. So if you see that x is sine theta over 2, well, that's sine theta over 2. So we just say that that's x squared plus y squared equals 1. because sine theta over 2 is x, cosine theta over 2 is y. So every time you see sine and cosine for your x and y, we just plug them in, and there's our equation. So it's a circle. And you already saw this one earlier, but it's got a radius of 1. So that is our circle. So now all we need to know is direction. I'm not going to even say what the x and y are here because it's a circle. We know it's from -1 to 1 and from 1 to 1. But if you want to write it, go ahead, -1 to 1, and our y is going to go from -1 to 1. Our t here, which should have been theta, this is called sloppy writing for me, is going to go from -pi to pi. So that will now affect our circle. Are we going to get a full circle, or are we going to get a partial circle? So let's erase these. Let's see what happens. So our theta is going from -pi to +pi and 0. But if you look at our trig functions here, what we have is a period of, well, we don't know what it is because it's got a divisible of 2. And so we have to go 2 pi divided by 1/2. And so that's 4 pi. So if you remember, if we put a fraction there, it's going to take that and do a multiple of whatever it is to the period, basically slowing it down, giving it a longer period. So our whole circle would need a full 4 pi to get all the way around. Do we have that? No, we don't. We have from -pi to pi. That's a 2 pi. So we're only going to get half a circle. But which half is it? Is it from here to here, or from here to here, or from here to here? We don't know. We've got to actually plug them in and see what happens. So let's look at our calculator. And you can use a unit circle for this as well, or just straight substitution. The first one is going to be -pi over 2, and -pi over 2 for both sine and cosine. So I've already plugged it in. You can see I've got my x is sine t over t over 2. My cosine is t over 2. I changed my window from -pi to pi. And then I'm going to use the table. So by the way, if you just hit graph, you already see it's the upper half. That's all we're getting here. But if we go to our table set, we can actually start it where we need to go, from -pi, right, to pi. And now I just want those marks. So I know it's only going to do half a circle, so I just need 1, 2, 3 marks, right? So if I just make it pi, that means I'll go from -pi to 0 to pi. And that'll give me my points that I need. Those 3 that I'm looking for here. So we have -1, 0. 0, 1, and then 1, 0. So our first point would be here. Our second point would be 0, 1. And our third point would be 1, 0. That gives us this direction from there to there. And now we have some erasing to do. So it's only this part here. So you can see by plugging in -pi, we get -1 and 0, 0, and 1. And then plugging in pi would be pi over 2, so we get 1 and 0. And that gives us our direction. So now our x, you can see, is still between -1 and 1, but our y value is between 0 and 1. You can see it here. Those are the values we get from -pi to pi. So that is our Cartesian equation. Those are our x and y's, and that's our domain. All right, so let's try another one. So this is as crazy as they get. You can see now that we still have that sine and cosine going on, but there's some other stuff in the way. So what you do is you just solve for it. So what we know is that cosine of pi theta squared plus sine squared of pi theta would equal 1, because sine squared plus cosine squared is 1 because they have the same pi theta. So now if we take our x and solve it, or cosine theta actually, we get x plus 5, sorry, I'm getting ahead of myself, that would have been a minus anyways, equals 5 plus 3 cosine of pi theta. So we get x minus 5 equals 3 cosine pi theta. And then now you just divide by 3. So we have cosine of pi theta is equal to x minus 5 over 3. And then we do the same thing with the y. So I'm going to just take one extra step here, just so we have a nice problem. All right, so y minus 3. And so you can see how you can get kind of quick at this. Not that you need to be. Divide by 2, divide by 2. So we have y minus 3 over 2 sine pi theta. So now, if you plug those in, so the cosine squared is this one. The sine would be this one. So we end up with it's an ellipse. And so if you keep going, this would be x minus 5 squared over 9 plus y minus 3 squared over 4 equals 1. So we have an ellipse. And I'm going to graph the whole one just because. So this would be 3 to the right, because remember it's the square root of 9. 3 to the right and left, and then 2 up, 2 down. But we are centered at 5, 3. So 4, 3, right there is where we're centered. And so that means we're going to go 3 to the right, put a dot, 3 to the left, put a dot, 2 up, put a dot, and 2 down, and put a dot. So now we have our dots, and so we need to look and see at our t minus 1 of how we're going to connect those dots and in what direction. So are we going to go this way? Are we going to go this way? Are we going to go all the way around? Or are we just going to go partially around? So let's see what happens. So we have t equals 1. And then a number between that would be like 1.5. And then 2. So if you look at it here, our period is 2 pi over pi, which is 2. So we need a full 2 for a full period. So we're not going to have enough here. This is from 1 to 2. So we're only going to get halfway around. We'd have to go all the way. So like 1 to 4, we should get all the way around. All right, so let's see what we get with our calculator. So we plug them in for our x and our y. Then we go straight to our window and go, my t is between 1 and 2. And then we graph. And so you can see it's just that bottom happy face. So all we're going to be doing is connecting these two like that. Now we want to see what the direction is. So if we go to our table set, we're going to start it at 1. And my change in table you can see is 1.5. Because again, we just need to see a direction change. So something in the middle is good. And there we are. So we would get 2, 3. Let's do these in red. 2, 3. And you can see there it is, 2, 3. So that is where we're starting. We know we're going this way. But let's just fill in the table anyways, just so that we have it. 5, 1, and 8, 3. Because that way it verifies everything as well. So you can see there's our 5, 1. There's our 8, 3. Now, this one does not actually include 1. It's only 2, 2. So when we plug in our x values here, plugging in t equals 1 gave us 2, 3. These are not included. So for our x values, our x is going to be between 2, not including it, and 8. And our y will be between 3, not including it, and 1. So I got to rewrite those so that we have them correct. That's 1, because that would make absolutely no sense otherwise. There we go. And you can see that it's here. So the 1's included, but the 3 is not up here, but it is on the second one. So 3 is included here, so we get to include it. Woohoo! Not that we needed this. All we really need is our Cartesian equation on this and our direction in our graph. But let's look at Desmos just to see it move so we can see that. So with those two equations with the parameter of t, you can see that is our motion. It starts over there and moves through here. So as t is plugged into both of these equations, we get that little smiley face. And we didn't do the previous one either, but there you go. You can see there's our motion as it moves across. So as t is plugged into those x and y's, from negative pi to pi, that's our graph. So these are our two types of trigs. So if you see sine and cosine, one as the x and one as the y, you're going to use sine squared plus cosine squared equals 1. And if you see x equals sine of t, you're going to try and plug it in throughout the problem. So use other trig identities to do substitution. But your whole goal is to get rid of that t or theta, whichever we're dealing with here. I need to change that one to theta as well.